You can take 2 to the power of a common in both of these. You will be left with 2 to the power of a into 1 plus 2 to the power of 1. 2 to the power of 1 is nothing but 2. 2 plus 1 is 3. So, you have 2 to the power of a into 3 as your answer. It's option E. Let's look at the next question. 3 to the power of x plus 2 minus 3 to the power of x is equal to 6 to the power of 3 into 3 to the power of 7. What is the value of x? 3 to the power of x plus 2 minus 3 to the power of x is equal to 6 to the power of 3 into 3 to the power of 7. So, let's express what is 3 to the power of x plus 2? 3 to the power of x into 3 to the power of 2 minus 3 to the power of x is equals to 6 is nothing but 3 into 2 whole to the power of 3 into 3 to the power of 7. Now, you can take 3 to the power of x common from both of these. You will be left with 3 to the power of x into 3 square minus 1. You have 3 into 2 to the power of 3. So, that will be 3 to the power of 3 into 2 to the power of 3. When you expand this, this is what you will get, and this into 3 to the power of 7. So, here you are left with 3 to the power of x into 3 square is nothing but 9, 9 minus 1, and here we can add 3 to the power of 3, we can multiply it by 3 to the power of 7, and it turns out to be 3 to the power of 3 plus 7, and your 2 is 2 to the power of 3. So, 3 to the power of x into 9 minus 1 is nothing but 8, and 3 plus 7 is nothing but 10. So, here you can write 8 as 2 cube. 8 is nothing but 2 raised to the power of 3. When you equate it to 3 to the power of 10 into 2 to the power of 3. Here, when the bases are same, you can equate the powers. Here the power of 2 is perfectly matched already. We are only left with 3 to the power of x is 3 to the power of 10. That means that x is equals to 10, which is option A. Let's look at the next question. If 3 to the power of m plus n is equal to 27 and 3 to the power of m minus n is equals to 1 by 3, then m by n is equal to what? 3 to the power of m plus n is equals to 27 and 3 to the power of m minus n is equals to 1 by 3. So, 27 is nothing but 3 to the power of 3. 27 is 3 cube. When you are writing 3 to the power of m minus n, 1 by 3 is nothing but 3 to the power of minus 1. So, when the bases are same, we know we can equate the exponents. So, here m plus n, we get m plus n is equals to 3, and we will get from this m minus n is equals to minus 1. We have two equations and two unknowns. So, m plus n, m minus n is equals to minus 1. When you add both of these equations, you will get 2m is equals to 3 minus 1, that is 2. So, therefore m is equals to 1, and n, you substitute this m is equals to 1 in this equation, you will get 1 plus n is 3. So, n is equals to 2. And what did they ask us? They asked us what is m by n. M by n will be 1 by 2, which is option C. Let's look at the next question. What is the greatest value of the positive integer p such that 2 to the power of p is a factor of 80 to the power of 50? So, when 2 to the power of p is a factor of 80 to the power of 50, that means that it is a multiple. If you can multiply the factor with another factor to get 80 to the power of 50. Let's expand 80 to the power of 50 so that we have the same basis, we can equate the powers. So, 80 is nothing but 8 into 10 raised to the power of 50 is equals to 8 is 2 cube and 10 is 2 into 5. So here you have 2 cube into 2 will be 2 to the power of 4 into 5 to the power of 1 whole to the power of 50. So when you expand this, you will get 2 to the power of 4 into 50 and 5 to the power of 1 into 50. So that is nothing but 2 to the power of 4 into 50 is 2 to the power of 200 and 5 to the power of 50. This is equals to, now let's substitute that into this equation, k into 2 to the power of p. When the bases are same, you can equate the powers. So p is equal to 200. This is the greatest value that p can take, such that is option E is our answer, such that 2 to the power of p is a factor of 80 to the power of 50. Let's look at the concept of cyclicity. Cyclicity, when you are calculating, will help you when you are calculating the units digits. When any digit that is single number is raised to any power, it will always show a pattern of its units digit. That means when you, let's look at the table of 2 raised to powers of 1, 2, 3, 4, etc. So 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, and we're just focusing on the units digit. So even though it's 16, we are only looking at 6. Then 2 raised to 5 is again 2. So the pattern will repeat again. Here the pattern is 2, 4, 8 and 6. Let's look at that. 2 to the power of 5 is 3 to the 32 and the unit digit is 2. Then 2 to the power of 6 is again 64, the unit digit is 4. 2 power 7, again it will come out, the unit digit comes out 8, and 2 to the power of 8 is 256 with unit digit 6. So look at the pattern here, 2, 4, 8, 6. This pattern repeats itself after every 4 counts in the power. So we call that a cyclicity. 2 has a cyclicity of 4. When you look at 3 to the power of 1 is 3, 3 square is 9, 3 cube is 27, 3 to the power of 4 is again 81. That is, you can only focus on the units digits again. Then 3 to the power of 5 is again 243 with unit digit as 3, and 3 to the power of 6, 729 with unit digit as 9. You look at the pattern, it chases 3971. If you check further, if you go further, 3 to the power of 7 and 3 to the power of 8, you will see that the unit digit will repeat itself after every 4 times. So 3 also has a cyclicity of 4, of 3971, 3971. This is how it's going to repeat itself. When the unit digit is 4, 4 raised to 1 is 4, 4 square is 16 with 6 at its unit digit, 4 cube is 6 to the power of 64, unit digit is 4, 4 raised to 4 is 256, which again it repeats itself. Here the cyclicity is just 2, 4, 6, 4, 6. This is the pattern that it's going to follow. So 4 has a cyclicity of 2. It repeats itself after every 2 numbers. Now let's look at 7. 7 to the power of 1 is 7, 7 square is 49, 7 cube you get 343, that's 1. 7 to the power of 4, you don't need to check the digits are expanding, so you can just look then that in the units digits you will get 7 into 3, that is 21, and but you're only focused on the units digit, so you will get 1. And if you further check 7 to the power of 5, in the units digits it will be 7, 1 into 7, so it will be 7 again. If you check 7 to the power of 6, it will be 7 into 7, that is 49. In the units digits we are only focused, so the pattern repeats itself after every 4 numbers. So 7 has a cyclicity of 4. units digit when it's 8, let's look at what happens. 8 to the power of 1 is 8, 8 square is 64, 8 cube is, you don't need to calculate the whole 8 cube, just 8 into 4 will give you the answer as 32 with 2 at the units digit. And 8 to the power of 4 is, again you will get 8 into 2, that is 6 in the units place. And 8 to the power of 5, 8 into 6 is 48 with 8 at the units digit, so you will get 8. And 8 to the power of 6 is again 8 into 8 is 64, 4 at the units digit. So this also repeats itself after every 4 numbers. So 8 has a cyclicity of 4 and the pattern is 8, 4, 2, 6. When you look at 9, you have 9 to the power of 1 is 9, 9 square is 81 with 1 at the units digit, 9 cube has 9 at the units digit, 9 to the power of 4 has 1 again. Here it is repeating itself after every 2 numbers, and that means that 9 has a cyclicity of 2. We haven't checked for 6, let's look at what happens when the units digit is 6 or 5 for that matter. 6 to the power of 1 is 6, 6 square is 36. Look at the units digit again, 6, 6 cube is 216. You look at the units digit, it is again 6. So 6 has a cyclicity of 1. You raise 6 to any power, always your unit digit is going to have 6. 5 has the same pattern, 5 to the power of 1 is 5, 5 square is 25, 5 cube is 125, it will always be 5, it has a cyclicity of 1, 2, 5 raised to any power will give you 5 at the units digit. And it is the same with 0, when you raise 0 to any number, it will always remain 0, so it is again having a cyclicity of 1. These are all numbers which have cyclicity of 1, that is you raise them to any number, they will have the same units digit, 0, 5, 6. Let's begin with the next question. What is the unit digit of 7 raised to 8 to the power of 6? We know that 7 has a cyclicity of 4. So what you have to do is look at the power, 86 divided by 4. So you will have 4 2s are, 4 1s are, 4 21s are plus a remainder of 2 divided by 4. So what you need to look at is, you have to look at the table again, 7 table, how the power is increasing. 7 square will be 49, but we are only bothered about the units digit, so forget what the other digits are. 7 cube will be 7 9s are 63, 7 to the power of 4, 7 3s are 21. We will have some numbers here as well. 7, yeah. So 7 to the power of 5, it again repeats, so you don't need to look at that. What our power is 86. When you divide it by the cyclicity, you have a remainder of 2. So you will have to check 7 to the power of 2. What is 7 to the power of 2? It has 9 at its unit digit. So 7 raised to 86 will also have the same units digit as 7 to the power of 2, the remainder when it's divided. So that is 9, that is option E is our answer. Let's see the next question. What is the unit digit of 6 to the power of 15 minus 7 to the power of 4 plus 8 to the power of 3? As we have seen, 6 has a cyclicity of 1, thus 6 raised to anything will give you 6 as its unit digit. And 7, we just saw the table. When you are looking at the table, so we might make the mistake that 7 to the power of 4, you divide the power by its cyclicity, that is 4, the remainder is 0. But you might make the mistake of choosing 7 to the power of 1, but what you have to choose is the remainder. Whenever it comes out to be 0, you will have to look at the fourth number, that is 7 raised to 4, that is 1 will be at your units digits when you have the remainder 0. 7 to the power of 4 is giving you a remainder 1 plus 8 to the power of 3, 8 we know has a cyclicity of 4. So we divide 8 is raised to the power of 3. 3 you divide by 4, it is nothing but it will remain 3. It's 0 plus the remainder itself is 3. So you look at 8 to the power of 3, it has 2 as the unit digit. So whatever be the other digits, when you are operating this, only the unit digit is of concern. So you can just add the unit digits and subtract the unit digit, whatever your question is asking you to do, and forget about the rest of the digits to calculate the unit digits. So 6 minus 1 is 5 plus 2 will come out to be 7, which is option B. Let's move to the next question now. If n is equals to 33 raised to 43 plus 43 raised to 33, what is the unit digit of n? So when you're calculating the units digit, you can forget whatever comes before the units digits. You're only concerned about the units digit. So n is equals to 33 to the power of 43 plus 43 raised to 33. So this will have the same units digits as 3 raised to 43 plus 3 raised to 33. We can forget whatever comes before our units digit, that is here it is 3 and 4, and just focus on the unit digit. Unit digit here is 3. So I wrote here 3 to the power of 43 and 3 to the power of 33. 3 has a cyclicity of 4. It has cyclicity of 4. So let's divide our powers or exponents by 4. We get 4 tens plus the remainder comes out to be 3. So it will have the same units digit as 3 to the power of 3, that is 7. So this will have 7 in its units digit. Now when you are looking at 3 to the power of 33, when you divide 33 by 4, you have 4 8s are 32 plus 1 by 4. So it will have the same power as 3 raised to 1. So that is 3. This has a unit digit of 7, this has a unit digit of 3. When you add them both, you get 10, that is 0. That will give you 0 at its units digit. So that's option A. Those were some sample questions on exponents. Hope they were clear. Thank you for watching.